I want to talk about a bit about myself, how I ended up here at the Swedish Institute of Space Physics in Uppsala, and a little bit about my research on Venus. So what I'm currently doing, as Colin said, I am a postdoctoral researcher at the Institutet för rymdfysik in Swedish. And the main focus that I have in my research is the plasma environment of different terrestrial planets, where my main topic so far has been Venus, but I'm also interested in Mars and Mercury, for example. And here you can see a very nice illustration of what this plasma environment can look like. This specifically is an illustration of how it can look like a Venus. So what you see coming in from the left here is the solar wind, which is a big sort of cloud of particles charged particles that the sun is continuously spewing out into the medium around it. And as it approaches different planets in our solar system, for example, Venus, it's going to start to interact with the planets. And depending a bit on how the characteristics of the planet looks like, this interaction will be slightly different. So for Venus, for example, it doesn't have a global magnetic field. It will be its upper atmosphere that interacts with this solar wind and creates what we call an induced magnetosphere. And it's these type of interactions that I study in my research. And I'm going to come back a bit to one of the major results that I got during my PhD. But first, I wanted to talk a little bit more about how I ended up studying this plasma environment of Venus. So, as Karin said, I grew up in a small village outside of Skövde, which is called Vässås. It's located here in between the two big lakes of Sweden. And it's a very small village. And in fact, I grew up outside of this village in a small farm where we had lots of animals, horses, dogs, cats, etc. And it's a quiet life. It's very nice upbringing, but it was very far from academia. And basically, no one in my family had gone to university and studied at an upper level. And so I didn't really know about these opportunities. And I was a very, very shy little person who barely had the courage to speak to anyone. And so thinking about doing this kind of research was very far from what I thought I would do in my future. But growing up on the countryside of Sweden, this is not my picture, but as you can imagine, when you have your neighbor, basically the closest neighbor is 1 kilometer away, you get very, very nice night skies on a clear day. And so you can see really the Milky Way, and you could see the planets with your naked eye. And it was very inspiring for me. In school, I was also very fascinated by the subjects of physics and math. And of course, space comes easily into this. And you can connect different space aspects in these subjects. And I was always thinking that, no, you cannot really work with that. It's just fascinating, but is it really something that you can work with? But people always told me that you should go to university. You seem to like this subject. And so I decided that, yeah, okay, I will go to university and see if there is anything for me within space, physics and math. And so I decided to do engineering. And by random chance, I saw this advertisement from Luleå University, where they had this master in space engineering. And I figured this must be where you study physics, space, and math. And in fact, yes, you do. And so I went to Luleå to study. And this is a quite special program because you study half of the time in Luleå and half of the time in Kiruna. And so I went first 2.5 years in Luleå, and then you go and do the rest in Kiruna at the same building as the Swedish Institute for Space Physics. in Kiruna. So the university, Lulu University students are located in the right wing here of this building, while the institute and all the researchers are located in the rest of this building. And so you're very close to space research when you're studying here. And I decided, because I was a very shy person, I wanted a lot of personal development, that I would dare to go on exchange studies. And I decided and managed to get 6 months of studying at the San Diego State University. And here I get the chance to study more astronomy. I studied the life of stars and the motions of galaxies. It was a super interesting 6 months, but I realized that maybe astronomy is not the thing for me. It's so far away and it's very theoretical, and you have very little data to work with. And so I was way more interested in studying things in our solar system. And so I went back to do, so I first was 1 year in Kiruna, then I went to San Diego, 6 months, and then I had 6 months more in Kiruna, where I started to get more into contact with the researchers at the Institute, and I started talking with them about project work, etc. But I needed to do a master's thesis. This is the last 6 months of your master course. And I thought, why not send emails to every cool person that I could potentially do some solar system physics research with. And I sent so many emails to so many people, and I thought, no one of these is going to answer me. But eventually, this researcher in Oxford University answered me, and he said, yeah, you can come here and work with Venus upper atmosphere with me. And this is where I started my journey into starting to love Venus, the planet Venus. So I did 6 months there, and during this time, I heard that they got funding to study for a PhD position to study Venus plasma environment at the Swedish Institute for Space Physics. And because I already had been in contact with them, I heard about this position, and I think some connections and some random chance led me to start and get this position and to study the plasma environment of Venus. And specifically, I focused on the ion flows measured by the spacecraft Venus Express, which was an ESA mission that actually ended right when I ended my master in engineering, space engineering. So there was a lot of random chance that led me to get this position. And so I had 5 years of my PhD here in Kiruna on this side of the building this time. And this Swedish Institute of Space Physics in Kiruna is located very beautifully outside of the city of Kiruna. And you have beautiful views of the aurora and reindeers and whatnot. And here I, of course, did my PhD at the Swedish Institute for Space Physics, but you have to be affiliated to a university. And the options there is either Luleå University or Umeå University, and it depends a bit on where your supervisor is affiliated. And my supervisor was Yoshifumi Futana. He was affiliated with Umeå University, and so I defended my thesis at Umeå University in 2020. And I'm going to come back a bit to what I did there. But first, just my story after that. After you finish your PhD, you are supposed to do some postdoctoral research positions. And these are short-term projects. Usually they have lengths of 2 to 3 years, and you do maybe 1 or 2 after your PhD. In my case, I got a bunch of short-term projects. Also a bit of random chance and luck that gave me these positions. First, after my PhD, I went to IRAP. It's a similar institute as IRF, but it's located in Toulouse in France. And there I got the chance to use data from the Bepi Colombo mission. Bepi Colombo is a mission that currently is on its way to Mercury. And it takes about 7 years for Bepi Colombo to reach Mercury, and on its way does several flybys of Venus. And one of those flybys I got the chance to analyze the data from. It was truly exciting for me. Also, I applied to get some funding from this Japan society to do postdoctoral research for 1 year at the University of Tokyo. And so I was very lucky to get that one. And I went to the Kashiwa campus, which is located slightly north of Tokyo. And there I studied Venus again, of course. But this time I used the Akatsuki spacecraft, or Akatsuki, which is a Japanese spacecraft that is currently orbiting Venus. And it's more focused on the atmospheric dynamics of the planet. And so here I studied more about gravity waves and how energy is transported in the upper atmosphere of Venus. And then after this, recently, just less than 2 months ago, I got a new postdoc position where I will go back to the Swedish Institute of Space Physics, but this time I am located in Uppsala, a bit slightly south of Kiruna, I would say. This time I'm going to another planet, unfortunately. This time I'm studying Mars, and I'm located at the Ångströmslaboratoriet in Uppsala University, and I'm studying this time the plasma environment of Mars, and mainly focusing on the ion chemistry, the upper atmosphere. And this is a 2-year position, so hopefully I can stay here in 2 years, and then we'll see what happens. So, with my background finished, I wanted to talk a little bit more about Venus, and one of the sort of main research findings that I had during my PhD, which I think is very exciting, because my research in the plasma environment about Venus is very related to the evolution of the Venusian atmosphere. Venus today is incredibly non-hospitable. The surface has temperatures of over 400 degrees Celsius, and the pressure on the surface is equivalent, it's 93 bars, which is equivalent to being 1 kilometer below the surface of the ocean. And so it's not that easy to go to Venus. And another thing is that there is basically no water on Venus. It's very, very, very dry. But Venus is should have started somewhere similar to Earth. It should have had water in the early history, and it should have been more hospitable for life. So what happened between then and now? And did Venus have this kind of liquid state of water in its early history? And so we can talk about how this water was lost. And this is where my work comes into play. And there's basically 2 ways that water can be lost from an atmosphere. At least 2 groups of things that can happen. One is the interaction between the surface material, the rocks of the planet, and the atmosphere. And the other way is for these water molecules to escape into space and be lost. And as you can imagine, my focus is on this second part, escape of atmospheric constituents to space.